Hello, this is Team Reacher, and this is the VV&T presentation for the flotation test. I am Brian Shee, the financial lead and aerodynamics lead here in the middle. The flotation test is a test where we place our aircraft into the water just to kind of observe its maximum water line to make sure that it won't interfere with the electronics or the propellers and stuff. It's a fairly simple test just to make sure that our design displaces enough water that it can maintain buoyancy. So the objective of this test is kind of to make sure that the water line is where we expect it to be and that water won't intrude through the waterproof coatings that we did onto the surface of our fuselage. This is to ensure that the water won't interfere with the electrical components, and it also won't and also the propellers won't strike the water when they're turning. This test is kind of designed for the driver requirements in regards to water landing, water resistance, the airplane is light, and that it can float. So for the experimental setup, the facility was at Lake Raleigh. Originally, we were planning to do it at Carmichael Pool, but because we weren't entirely confident that Flexiol was non-toxic, we didn't want to take the risk, and we chose to do it in a larger body of water, such as Lake Raleigh. For the equipment and stuff, it was fairly simple. It was just our aircraft in a large body of water. And the procedure is honestly also very simple. We take our aircrafts to the lake, then we assemble it by the body of water, and then we just set it down into the water to observe where the water comes up in the fuselage. So once we do that, we want to make sure that first of all our plane floats and doesn't just sink immediately, and then we check the clearances between the propellers and the water line, and then we let it sit for 5 minutes just to ensure that it doesn't really start sinking over the next few minutes. And then afterwards we take it out of the water, and then we check the insides and make sure that it's still completely dry. And that should just prove our aircraft can float and that it will float for longer periods of time. So this is the video that we took while doing the test, and I'll just let it run. 3, 2, 1, go ahead.
The balance seems better than it was the other day anyway.
Cool. Can you guys tilt the front motors down? Okay. And then
it's like right at our water line, which is kind of cool. I mean, it's a little tail heavy, but
yeah, but that's
in the water.
That's actually good for that.
We knew that was going to be the case.
Yes.
Okay. That's about 2 inches.
And we can also adjust that by. I'll let him do his video.
Yeah. No. Looks like it's about 1 inch.
Okay.
How far is the back from the spin around again?
Here.
Just do like the bottom of the motor.
Alright, so bottom of the motor, we have 2.5 to the very bottom.
Okay.
This.
Cool.
And then at the tail, we have 3.
Okay. Well,
Do you want me to do a video of you doing your presentation?
no, I was gonna do talk over. This is just like the actual demo part.
Is that all you need? Do you want to get in the water with it? Or?
I mean, all I really need now is just to let it be in the water for 5 minutes. So,
Alright. Should we just let it sit like this for 5 minutes?
if you want, yeah.
Do you have a timer going?
Just try to remember the video.
Have some Doritos. I should have brought some Doritos.
Yeah.
Where did the guy in the boat go?
Really nice.
We might need him.
Yeah.
Oh, wait a second. This boat's falling off.
Voice phone?
It is a little bit.
Because it's not glued on there or anything.
Yeah, that'll be permanent for the final one. So,
make sure this thing doesn't freak out. You probably should just like tie a string to it, just in case. Like, you get distracted. Maybe. All I did was that, and it's like, oh, what it works.
I wonder how much bigger our floats are going to be compared to these. Maybe double the size?
Probably.
Yeah, we just gotta figure out how to make them aerodynamic.
Yeah.
And we need them to be glued in like tightly, but they need to be like the floaty-ish part needs to be further as far like back as we can get it. You know what I'm saying, Buzz?
Yeah.
Okay.
Yeah.
Yeah, I can have it where they mount at the front of the float so the floats hang.
Yes.
That's why we have them angled back anyway.
No. No.
Do you have a timer going or just rolling?
It's 3.5 minutes, so we're pretty close.
I really wish we could just like start and drive it around.
Yeah.
We better win.
Why does it want to twist that way? Is that just how the water's moving right here? You see that? Like it's just wanting to do this.
Positive yaw stability.
Is that what it is?
No.
I thought it was spiral instability.
I don't know. I don't think there's enough wind for it to be yaw from the tail or anything.
Let's see if it starts going the other way.
No. It's not gonna. It's really. Or maybe it'll just go out. See.
Now it's stationary.
Okay, it's about 10 more seconds and I'll be done.
Then we can do your video, Lucas.
Cool, that's 5 minutes.
Let's go.
Can you bring it in? Just
Yep.
open up inside, just visually check if there's any water. I doubt it, but
Now all the epoxy looks wet too, so don't freak out.
yeah.
All the epoxy looks wet, so.
All water epoxy.
The epoxy that's inside. I'll just take it out of the water. Okay.
Might as well.
Well, no, because it was tacky when it got on the control surface stuff.
Big step. Big step guy.
Stretch. Okay. That's supposed to check.
Looks dry.
That's all epoxy stuff.
Yeah. Anything that looks wet, just epoxy from before. Cool.
Okay.
And I'll go on to the next video, which is afterwards in the lab. This is just a follow-up video, but we're back in the lab and everything looks dry. Anything that's shiny is epoxy from before, but it looks like the fuselage is watertight. Oops. There we go. So from the videos, you can see that the front left propeller had 1 inch clearance from the waterline, the front right propeller had 2 inches, and the rear motor had 2.5 inches of clearance. So I suspect that the difference between these is more so because the floats between the left and right wing weren't entirely symmetrical. Since these are temporary, we didn't put too much work into them. So I do believe the right float is about 2 or 3 inches longer than the left float, which could explain the kind of off-centered buoyancy. So after 5 minutes, there is no detectable changes in the buoyancy of the plane, so there's no risk of it sinking or anything. And then afterwards in the lab, we couldn't find any water in the internal compartments, so we also assumed it was basically waterproof. So I would also want to talk about, we didn't have the batteries in there since that was too much risk, but we chose to keep most electronics, such as the flight control and wires in there, because there's significant risk in us damaging electrical components in the process of removing them without removing the wooden frame. So we kind of just chose to leave them in there, and without the battery, it was mostly safe. It was basically entirely safe. So for results, we met the level 2 requirements that all propellers had to have at least 1 inch clearance. The stats of this test was completed, and the biggest challenge was kind of working with our primary sealing agent, which was Flexiol, and our primary structural agent, which was XPS foam. These two materials don't really work well together, since if you spray Flexiol directly onto foam, it will just kind of dissolve it. So we had to go through a fairly laborious step of covering the foam in like a paint primer first. However, since this wasn't entirely perfect and we had some holes in the primer, once we sprayed the XPS, or once we sprayed the Flexiol into the foam, there's small holes which may lead to leaks, but functionally for the overall design, it was waterproof. As a summary, this test showed that our aircraft could float, and it could float for extended periods of time. And also we had enough clearance from the propellers that it could do a CTOL takeoff. So even for STOL or VTOL, where the propellers are kind of tilted upwards, so like for STOL, the propellers are kind of tilted upwards or at 45 degrees, and for VTOL, the propellers are tilted up all the way up at 9 degrees. So in these cases, there's going to be even more clearance between the waterline and the propellers, so there's really weren't an issue at all. Kind of caveat is that this test was done in basically a super calm day on a calm lake, which is very different from what we expect our aircraft to be actually deployed in. Like post-hurricane, we expect there to be kind of choppy waves and higher winds. So if we redid the test on a stormy day, we would. However, I don't expect the actual results to be much different considering how much clearance we had. And that concludes the presentation. Thank you.